Hey everyone, and welcome back.
We often look up at the stars and wonder what's out there. But what happens when what's out there comes to visit? In late 2025, Mars is about to get a very close visitor, an interstellar comet named 3I Atlas, and it's unlike anything we've ever seen. This isn't your typical comet. Its coma, the fuzzy cloud around it, is loaded with carbon dioxide, ready to unleash a flood of charged particles at rates our Mars orbiters have never experienced. As it flies by, scientists predict the entire Martian ionosphere could ignite, creating spectacular planet-wide auroras.
But this isn't just a light show.
These surges in the ionosphere can overwhelm spacecraft sensors, trigger safety systems, and even knock out communications. Imagine mission control suddenly going dark. To make matters worse, magnetic hotspots in Mars's southern highlands could act like giant amplifiers, focusing electrical currents and creating localized storms of electric charge. Engineers are on high alert for something called single-event upsets. Tiny, invisible jolts that can scramble an orbiter's memory or navigation, forcing it into safe mode without any warning. Even if not a single piece of the comet hits Mars, the electromagnetic shock waves could cripple the entire fleet of spacecraft orbiting the planet. For mission controllers, the biggest danger might be the one that leaves no crater, but leaves them completely blind. But the concerns don't stop there. Planetary protection officers have spent years preparing for the possibility of finding life on Mars. But the rulebook has a huge blank chapter: what to do about an interstellar object carrying alien organic molecules. As 3I Atlas passes Mars, its carbon dioxide-rich coma acts as a delivery system for complex carbon compounds. If even a tiny fragment or a bit of dust from the comet lands on Mars, it creates a massive dilemma for every future mission searching for life. How would we distinguish between genuine Martian life and contamination from another star system? A few organic-rich grains could blur the lines, turning the monumental search for life into an endless debate over false positives and imported noise. And the potential fallout could get even more dramatic. If larger fragments from the comet collide with Phobos, Mars's fragile inner moon, the consequences could be planetary in scale. Phobos is already a fractured, delicate body, barely holding itself together. A high-speed sandblasting from cometary debris could be the final push that shatters it, scattering rubble into orbit and creating a temporary, hazardous ring around Mars. For our orbiters and future missions, this isn't just a navigation obstacle. It's a moving minefield, with fragments big enough to destroy satellites or start a chain reaction of collisions. In a worst-case scenario, Mars could gain a ring overnight, and we could lose safe access to its skies for years to come. The beauty of a new ring would come at a devastating cost to exploration. Now let's zoom out. Not every piece of 3I Atlas will stick around Mars. Some fragments, gently nudged by the faint but constant pressure of sunlight, a process known as the Yarkovsky effect, will begin a slow, decades-long drift. Their orbits will stretch and shift, creating a nightmare scenario for planetary defense strategists. This is debris that escapes immediate detection and then quietly migrates, sometimes toward Earth's own orbital path. Gravitational nudges from Mars or Jupiter can amplify this drift, sending fragments onto new courses that could cross the paths of future spacecraft or, in rare cases, even head toward us. Most will never pose a threat, but even a 1 in 1,000 chance over a century is enough to keep risk analysts awake at night. These interstellar relics are incredibly hard to track. They're dark, have irregular shapes, and tumble unpredictably, making them invisible to systems designed for typical asteroids. The legacy of 3I Atlas, then, isn't just about the chaos it might cause around Mars. It's a long-term story of uncertainty, with Earth as an unlikely, but not impossible, final chapter. Mars is a planet of delicate balances. A thin atmosphere, rusty dust, and just enough sunlight to keep its surface from freezing solid. When an interstellar object like 3I Atlas sweeps past, its carbon dioxide and dark dust can tip those scales, even from a distance. A sudden injection of these materials doesn't just cloud the sky. It changes how much sunlight reaches the ground. This alters the planet's albedo, its reflectivity, which is a critical factor in climate models. A dimmer Mars would cool down rapidly. This would create huge problems for our solar-powered rovers and future plans for using Martian resources. But the physical effects are only half the story. The flyby happens when Mars is hidden behind the sun, creating a communications blackout. During this silence, rumors could easily outpace data. Imagine social media exploding with speculation about secret impacts or disastrous terraforming events. Mission planners would find themselves not just battling dust, but battling to keep the facts ahead of viral misinformation. In the end, the real hazard might be the stories that spread in the dark, shaping public trust and the future of Mars exploration long after the dust settles. And the timing couldn't be more dramatic. In late October 2025, as 3I Atlas makes its closest approach, our own sun will be peaking in its activity cycle. Known as Solar Cycle 25, space weather experts are bracing for a storm. We're talking about massive explosions called coronal mass ejections and powerful solar winds. During a solar max, the sun can unleash several major eruptions every week. Now picture a powerful solar storm slamming into the comet's huge, gassy coma, right when Mars is in the crossfire. The resulting electromagnetic chaos could be more intense than anything we've ever recorded at Mars. For the fleet of orbiters and rovers, this is the perfect storm. Multiple hazards at once, unpredictable plasma, and a communication blackout when every system is already on high alert. The absolute worst-case scenario is sobering. If a large fragment of 3I Atlas, say the size of a city block, actually hits Mars, the consequences would be catastrophic. Dust clouds thrown high into the atmosphere would cut sunlight in half, causing surface temperatures to plummet by as much as 20 degrees Celsius for months or even years. Solar-powered rovers like Curiosity and Perseverance would grind to a halt. Orbiters would lose their lock on the stars and their signals would vanish as electromagnetic pulses rip through the ionosphere. Within weeks, mission control could be met with silence from half the robotic explorers at Mars. The loss wouldn't just be about hardware. It would mean the erasure of decades of climate data, vital experiments, and our only eyes on the red planet. For risk officers, the ultimate disaster isn't just a single impact. It's a long, dark Martian winter and a planet-wide blackout that wipes out a generation's worth of work. This encounter is a massive wake-up call. Being prepared in the age of interstellar visitors means more than just watching the skies. It demands a new kind of planetary defense, one that can operate even during a total blackout. In the aftermath of 3I Atlas, space agencies are pushing for a dedicated early warning grid, not just for Earth, but for Mars and the space between. The lesson is clear. Every gap in our coverage is a vulnerability. We need real-time analysis of electromagnetic surges, atmospheric changes, and dust levels. Scientists are also calling for more open data, arguing that transparency is the best defense against fear and misinformation. The new priority isn't just to find the next interstellar object. It's to build a system that can spot the subtle, silent, and strange before they rewrite the rules for every world we hope to explore. So, let's recap. On October 3, 2025, 3I Atlas will pass incredibly close to Mars. This is the first time an interstellar object will have a close encounter with a planet where we have active missions. This comet is a true outlier. Its CO2-heavy coma and unpredictable behavior defy all our existing models. The solar conjunction means we'll be flying blind during the most critical moments. Official assessments have documented the risks, but the true extent of the danger remains unknown. What is clear is that this event is a turning point. The 3I Atlas flyby, whatever its outcome, is forcing us to confront hazards from beyond our solar system and to rethink how we protect our endeavors in space. Thanks for watching. What do you think is the biggest risk from this flyby? Let me know in the comments below. And if you found this journey to the edge of the unknown fascinating, please hit that like button and subscribe for more deep dives into the cosmos. See you next time.